The National Electrical Code, or NEC, does not specifically mandate that hot water jumpers be bare conductors. However, it is a recommended practice to use black insulation with green tape to clearly distinguish them. According to NEC 250.119, A. Equipment grounding conductors must be identified with a continuous green color or a green stripe if within a cable. NEC 250.119. B specifies that grounding conductors in a flexible cord should have a green covering or green tape markings at each end. The advantage of using black insulation with green tape lies in its clear identification of hot water jumpers as grounding conductors. This prevents them from being confused with other conductor types. This practice aligns with industry standards and aids in adhering to electrical codes. Proper identification is crucial for safety, reducing the potential for electrical shock or fire by preventing accidental contact with live wires. While the NEC doesn't explicitly prohibit it, bare conductors can be used for hot water jumpers in specific situations. When using bare conductors, it's vital to implement extra safety measures. These measures ensure proper bonding and grounding. Such precautions include securely terminating the conductors and utilizing insulated ferrules or other protective devices. It is important to remember that the practice of using black insulation with green tape is exclusive to hot water jumpers. It should not be applied to other types of conductors, like phase or neutral conductors. Hot water jumpers should be kept separate from other conductors. This prevents the possibility of cross-contact. It is essential that a qualified electrician performs electrical installations and maintenance to ensure safety. When considering grounding and bonding, it's essential to understand the principles behind them and how they relate to safety. Firstly, grounding refers to connecting electrical circuits or equipment to the earth, establishing a reference point of 0 volts potential. This connection is typically made through a grounding electrode system, such as a ground rod or a metal water pipe. Secondly, bonding involves connecting metallic parts of electrical equipment or systems to create a low impedance path for fault current to flow back to the source. This path facilitates the operation of overcurrent protective devices like circuit breakers or fuses, which quickly disconnect the circuit in case of a fault. The purpose of grounding is to provide a path for fault current to flow safely to ground, minimizing the risk of electric shock. Bonding ensures that all metallic parts are at the same electrical potential, reducing the risk of voltage differences that could cause shock hazards. Effective grounding and bonding are essential for preventing electrical hazards and ensuring the safe operation of electrical systems. The NEC provides specific requirements for grounding and bonding to ensure that electrical systems are installed and maintained safely. These requirements cover various aspects such as the size and type of grounding conductors, the methods for connecting grounding electrodes, and the bonding of metallic equipment and enclosures. Proper grounding and bonding are critical for protecting people and property from electrical hazards. When working with electrical systems, it's important to follow the NEC guidelines and consult with a qualified electrician to ensure that grounding and bonding are properly implemented. For example, let's consider a scenario where a metal enclosure containing electrical equipment is not properly grounded. If a fault occurs within the equipment, such as a wire coming into contact with the enclosure could become energized. Without proper grounding, a person who touches the energized enclosure could receive a dangerous electric shock. However, if the enclosure is properly grounded, the fault current will flow safely to ground through the grounding conductor, tripping a circuit breaker or fuse and energizing the circuit. This prevents the enclosure from becoming energized and eliminates the risk of electric shock. Similarly, bonding is important for preventing voltage differences between metallic parts of electrical equipment or systems. If two metallic parts are not properly bonded together, a voltage difference could develop between them due to a fault or other electrical disturbance. A person who touches both parts simultaneously could receive an electric shock. Bonding ensures that all metallic parts are at the same electrical potential, minimizing the risk of shock hazards. In addition to protecting against electric shock, grounding and bonding also play a role in preventing fire hazards. Fault currents can generate heat as they fly through conductors. If a fault current flows through a high-resistance path, such as a loose connection, the heat generated could ignite nearby combustible materials and cause a fire. Proper grounding and bonding help to ensure that fault currents flow through low-impedance paths, minimizing the risk of overheating and fire. Maintaining effective grounding and bonding requires regular inspection and testing of electrical systems. Grounding connections should be checked to ensure that they are tight and free from corrosion. Bonding connections should be verified to ensure that they are intact and providing a low impedance path. Grounding electrodes should be tested to ensure that they are providing an effective connection to earth. Any deficiencies in grounding or bonding should be corrected promptly to maintain the safety and reliability of the electrical system. Furthermore, it's important to understand the different types of grounding systems used in electrical installations. These systems include the grounded or neutral system, the ungrounded system, and the impedance grounded system. Each system has its own characteristics and applications. The grounded system, which is the most common type, has one conductor that is intentionally grounded, typically the neutral conductor. This provides a reference point of 0 volts potential and helps to limit voltage fluctuations. The ungrounded system, as its name suggests, does not have any intentional connection to ground. This type of system is often used in applications where continuity of service is critical, such as in hospitals or industrial facilities. The impedance grounded system uses an impedance, such as a resistor or reactor, to limit the ground fault current. This can help to reduce the magnitude of fault currents and minimize the risk of damage to equipment. When selecting a grounding system, it's important to consider the specific requirements of the application and the potential risks involved. Consulting with a qualified electrician is essential to ensure that the appropriate grounding system is selected and installed correctly. In addition to the NEC, other codes and standards may also apply to grounding and bonding in specific applications. These codes and standards may include requirements for specific types of equipment or installations, such as telecommunications systems, fire alarm systems, or healthcare facilities. It's important to be aware of all applicable codes and standards and to ensure that grounding and bonding are performed in accordance with these requirements. Proper grounding and bonding are essential for electrical safety. Following the guidelines outlined in the NEC and consulting with a qualified electrician can help to ensure that electrical systems are installed and maintained safely. In summary, remember that the NEC doesn't dictate bare conductors for hot water jumpers, but recommends black insulation with green tape for clear identification. This helps prevent confusion with other conductors. The green tape readily identifies grounding conductors. This method aligns with industry practices and code compliance. This leads to improved safety by preventing accidental contact with live wires. While bare conductors are permissible under certain conditions, extra precautions are necessary. These include secure terminations and insulated ferrules. Importantly, this color coding should only be used for hot water jumpers, not for phase or neutral conductors. Always isolate hot water jumpers from other conductors to avoid cross-contact. Engage a qualified electrician for all electrical work to ensure safety and proper installation.